So the next speaker is Janus Juul Rasmussen, the CEO and I think founder of Valcon Design. Yeah.
Okay, hello.
Thank you, Rod.
Okay, I'll just start with telling a little bit about my personal background, because I didn't know that I was going into robust design, and now I'm standing in an academic environment. I'm standing with people who can do tolerance analysis. I'm standing with people who are so deep in that knowledge theoretically. I'm actually very practical in my background. I've done machines since I was 5 years old. I love machines. I've gone to DTU due to I wanted to be better at making machines. The background is actually kinematics. I've been working with kinematics and moving mechanics for the last 15 years. But I've also always had a feeling that what is good design? What is it? Some of us has it in our stomach feeling. We actually know it. We can actually see it. When Niels is actually showing these devices, we can actually go in and see, is this right or wrong? But it's very, very difficult to communicate. So I have 10 minutes now. I'll not be able to explain it. But actually, I'll try to go a little bit in about mechanical excellence. What is it? What should we actually look about? How can we actually manage it? Because as Niels is saying, our managers in the large companies, KPIs, economics, all these, if we can't as a society and as a domain tell them what is good and bad, how can they control it? Where to know how to put resources in it? So we actually need to challenge ourselves to say we need to know a little bit. We need to be predictable. We need to have that as the bar for our work. Okay, I'm coming from Valcon. We are a consultant house with 300 people. I'm in the design department where we are only having robust design. Only, that's a big field, but we are doing robust design consultancy. That one. Robust design is something we like it. It's nice. It's like getting rid of complexity. It's nice. It's like having design for manufacture. It's nice. Design for assembly. It's nice. But what is it? What is the drivers to actually achieve these nice things? We need to focus a lot into the drivers for design. We can measure if we have it. We can see if we don't have it very easily. Definitely when we go to market, we can see it. But when the designer is doing the sketch, his first little sketch of his feature, is that right or wrong? Can we actually tell something about that? Because we need to actually start in that early stage. Because if we don't have that driver, how would we then actually measure it before it's too late? Then we can test it, but if all the product we test is not the right ones, it will still not get better. So we need to actually focus a lot in what is the design detail. I'll say that predictability is extremely important. Predictability is coming, as I see it, before reliability, before cost, before everything, because predictability is actually what makes it possible for you to start a loop of iterating and actually starting being better. If it's a lottery where suddenly you have a very high reliability, a very low cost, okay, you won the lottery. What about next time? If we suddenly go into a more predictable world, we can actually start increasing and starting being better and better and better. And that will bring us to a total another level. I've been very inspired by production. Normally an R&D guy, I don't like production, but I like production. I think they are so good. I think it's amazing what they can do. I've seen design. We call it design for manufacture. Sometimes I call it design for miracle, because it's how can they produce these things? But they're actually doing it. It doesn't, for 14 years ago, they were not able of doing that. They have been into a change where they have their driver has been removing waste, and they have been measuring deviations all the time. And it has brought them to a level which is sometimes we can't imagine what they can do. mechanical design, what is actually our driver? Of course, we have a lot of drivers. It's a little rough, this one. But as I have learned it, we iterate. We do a lot of variants, and then we select it, mainly by experience, mainly by bad experience. Don't select what went wrong the last time. Then we measure, we simulate, and we build it, and we test it. But these dots up there, representing one solution. Can anybody tell us are there actually one of these which are right? We don't know. Then we can do some more and more and more and more. But actually, we need to be a little more objective to actually find out how to actually work this way, as I see it. Kinematics. I will claim that most product is only geometry. It is. It's actually mastering the geometry discipline that actually tells us if a product is robust or not. Our CAD system, whatever, of course you can specify material. You can calculate tolerances. You can do a lot of different things. But actually our CAD system and how we are modeling the products is geometry. The discipline that describe locations between different components in geometry is kinematics. It has been there for, I don't know how many years, a lot of years. And it's actually not something we need to try out. It's actually something we know. So we can actually have a lot of the iteration removed by actually looking much more into kinematics. In Novo Nordisk, it's called coupling degree. We have decided to call it predictability index. It's actually putting an index, how good is the geometry. It looks a little bit like the lean philosophy. Do we have waste in the geometry? Do we have geometry we don't need? Then remove it and measure it. Because then suddenly we can improve, and suddenly we can come into a learning loop where we don't just iterate. I like iterations, but not with everything. We need to iterate where we don't know. We shouldn't iterate in things where we know. And geometry, we know. I've been thinking, why are Novo Nordisk pioneer in this area? Why this little Denmark here? What have we in Denmark? We don't have cars. We don't have all these large companies. I'll claim we're small. We used to do a lot with a little. And we have some quite strong background within mechanical engineering. And I'll just put some pictures on it. I love that one. That's one man's work. To do the most precise, accurate, we have a history, we have a background with this one. We have a university which has a background within mechanical engineering. We're actually a spot of people who are used to do a lot in a little area. Novo Nordisk is using a lot of effort about finalizing 12 pieces, 12 parts. It's amazing how much work you can put in 12 parts. A blacksmith would say it's not possible, but it is, and you can continue, and they're not even finished. The next one, I love that one. It's not something that they were very experienced at these. They were good. They were good in designing, and to make a magnet measurement system which is that accurate, by far the best in the world. If we look in, I know a little bit about it, if we look into the sensor itself and look into its kinematics, it's a beauty. It should be, because else you will not have that, the world's best measuring system. It's not rocket science. It's not actually, yeah, maybe it is that, but it's, but actually, it's geometry. We need to understand the geometry. We should not just measure it. We need to know it. We need to have insight in it. Maybe I forgot some of the Danish companies, but we have Novo Nordisk, we have Vestas with the turbines, we have Grundfos with pumps, hearing aids, thermostats, car stereos, Lego, who is over here. I don't have a place to the picture there, but they are all recognized as the best of their kind. They're extremely good at doing this. And again, it's fine mechanics. It's actually very good products. So, based on this strong tradition for design, geometry and kinematic insight, and then a vision to actually change the design by making the robust design process much less iterative and much more based, much less based on experience. I actually have a strong belief that we can do this. It's time to actually change the way we're working. We cannot just iterate anymore. We need to go into a domain that the production has changed to a total another level. We need to do the same in R&D. And one of the first parts is actually the definition of robust design, actually being able to put KPIs on and then work in that direction. So I'm very excited to actually be here and to participate and actually contribute as good as I can to this conference. Yeah.
Thanks, Janus. Thank you very much.
Thank you.
Give it to Martin.